Okay, now we will do our final exponent rules and just a lot more simplifying examples. Okay, here is a review of what you've done so far. So all of this is done in lecture 18. If you want to take a look at these examples, just pause the video and make sure you're completely up to speed before we keep going. All right, so before we actually give you the rules, I just want to give you some motivation. So let's look at 2 to the third over 2 to the first. I want to move to the right, just using common sense, and to the left, using our rules. So 2 to the third, well, we know what 2 to the third is. 2 to the third is just 8. So we can write that as 8 over 2, and 8 over 2 is 4. So that's just kind of one way of thinking of it. If we looked at our rules, the rules that we did in lecture 18, 2 to the third over 2 to the first, well, there's a common base. 2 is the common base. So I would subtract my exponents, and I'd get 2 to the 3 minus 1, and 3 minus 1 is 2. So I have 2 squared, and that does equal 4. So regardless of whether we think about it in terms of rules or common sense, that makes sense. Okay, let's go down to the next one. Using common sense, we'd get 8. 2 to the third is 8. 2 squared is 4. And 8 over 4 is just 2. Okay, let's go the other direction. They have a common base, so I'll subtract the exponents. So I get 2 to the 3 minus 2, which is 2 to the 1. So 2 to the first power is just 2. That totally makes sense. That works. Let's do the next one. 2 to the third over 2 to the third. That's 8 over 8, which is 1. Now let's use our rules and see what happens. I have a common base, so I subtract my exponents. That is where I might get something a little bit surprising. I get 2 to the 0 power. If you think about it, it kind of makes sense if you think about it with your eyes half closed. 2 to the 0 power. It says if I multiply by 0 2's, that's like multiplying by 1. If I multiply by 2 2's, that's like multiplying by 4. If I multiply by 1 2, that's like multiplying by 2. If I multiply by 0 2's, it's just like I multiplied it by 1. So anything to the 0 power is 1. That's my next rule. Anything at all to the 0 power is equal to 1. Now let's look at how we would use that in some examples.
Okay, here are some examples of using the 0 power. So I want you to pay close attention to what that 0 has power over. So for the 3 times x to the 0 times y, who does 0 have power over? It only has power over the x. So x to the 0 power is 1, so it's just 3y. Don't think of it as just disappearing. It can't just disappear. It needs to turn into a 1. And if I multiply by 1, then it ends up being absorbed. It kind of does disappear, but don't think of it just being disappearing. The thing that most people will make a mistake on in this, even though it's easy, is they'll turn it into a 0 instead of a 1. It needs to turn into a 1. So now I have this big complicated thing, w to the 4th, x to the 14th over x to the 5th, z to the 23rd, all to the 0 power. As soon as I see that 0 power, anything to the 0 power is 1. And I'm done. That's good there. Okay, let's look at this next one. It's even more complicated. Who does that 0 have power over? Only the stuff in those parentheses. So all of that stuff in parentheses to the 0 power turns into 1. Plus 3 squared. It doesn't disappear. It's not 0. That doesn't just turn into 3 squared. It's 1 plus 3 squared. Anything to the 0 power turns into 1, which is 4 squared, which is 16. So we'll use that a little bit in future examples, but we won't have any other examples as explicitly messy with zeros in them.